All right, well, for us, it is our first day back from spring break. I'm not sure when you're watching, but for our seniors, it's been a week and a half since we've had class. And I mentioned circles a moment ago, and they had this blank look on their face like, oh, yeah. So let's review. I mentioned Conic Section, like, so let's see what we remember here. Remember, a conic section is that right circular cone that comes to a point, goes back again, right, and is intersected by a plane. And we said there's a number of different conic sections, some of which we've already looked at. A single line is a conic section if the plane goes along the edge of the cone tangent to it. A point would be where the plane intersects the two cones at their two sectional intersections. You could get a couple of intersecting lines if you put the plane right through the vertex of the cones. You get a couple of intersecting lines. But there were 4 conic sections we were going to be studying in chapter 12. I mentioned one of them already, class, the circle, but there's 3 others. See what we remember from a week and a half ago. Ellipse, parabola, and hyperbola. There we go. Okay, and we said that for these different conics, there's a term that describes their uniqueness, their weirdness, but their uniqueness. And it starts with an E.
Eccentricity.
Wow, I'm impressed we remember that. Eccentricity, great job. And we said, by the way, for a circle, there's nothing weird about a circle. It's perfect, right? And anyway, so what is the eccentricity then of a circle? 0, right? All the other conics are going to have different eccentricities, but for a circle, it's 0. We said all conics that we will talk about fall into a certain format for their equations. Do you remember what that format is for the conic equation?
A squared plus by squared plus cx plus dy plus e equals 0.
There you go. All conics are going to fall into this format that we're going to talk about. And technically, you could have an xy term here in between. For our purposes, our conics aren't going to involve xy terms. Okay? Now, we said that right here, this is really kind of the key. We said for a circle, what's going to be true about the A and the B? They have to be the same value. And for our purposes, we're going to make them ones, but they have to be the exact same value and, of course, positives then for a circle. If one is a different value than the other but still positive, that gives us the ellipse. For instance, you might remember something like 3x squared plus 12y squared equals 24. Well, that would be the ellipse because they have different numbers where 3x squared plus 3y squared equals 24, we said it would be a circle. Now, we kind of ditched this part of it, right? But when we talked about it there, we said if you don't even have, for instance, if you don't even have a squared on the second variable, one of them is squared, but the other square is missing, maybe you just have one of those, then it would give you the parabola. That's good memory there. One squared, one's not. And then the other one was if there was a negative in here. Well, then it wouldn't be a circle or an ellipse. If one of them's negative, it would have to be the B, by the way, otherwise we change the signs. But if one is negative, we would get the hyperbola. Now, hyperbole, okay, that's the exaggeration, right, from English class, but hyperbola. And one of my favorite comedians is Brian Regan. He's relatively clean. He's just funny. He takes everyday life situations, makes fun of them. But one of his jokes I remember, he acts like he's stupid, but you can tell from his jokes he's actually really, really smart. Like the things he comes up with, he has to be really smart. But he acts like he's stupid. You know, he's like, this guy came up to me after one of my shows, and I mean, I know I'm not smart and all, but he came up to me, and instead of being like, hey, I really enjoyed the show, he's like, you know you mispronounced every word in your show. If that is not the epitome of hyperbole. So anyway, those people with a good vocabulary get it, and other people are like, huh? Anyway, I digress. But hyperbola, right, is the other one. A circle. Obviously, it's a conic section, but all of our conics are going to be defined in terms of their locus, a locus of points. What's the circle's locus of points? Do you remember? The locus of points, from a
Given point.
given point, where the given distance is the,
Radius.
and the given point is the.
Center.
So in other words, a circle is defined by two things,
Radius and center.
radius and center. That's the whole premise of a compass, right? You open a certain amount, that's the given distance, that's the radius, and you put the point somewhere, that's the given point is center, right? And then you can draw the circle. By the way, you will want a compass tomorrow. So bring a compass with you tomorrow. Yeah, by definition, that's what a circle is. So we had a circle form of an equation, and it basically showed you the center and the radius, since those are the two things that define the circle. What was that circle form? Do you remember, Jamie? We let him shine a moment ago with the conic.
X minus x1 squared plus y minus y1 squared equals r squared.
There we go. And this is my circle form, or sometimes called the center radius form, because it shows you the center and radius of a circle. So for instance, if I gave you the equation x minus 5 squared plus y plus 3 squared is equal to 16, what would be the center of the circle? What would be the radius of the circle, Quentin?
The radius would be 4, and the center would be -5, 3.
Remember, the form calls for the negative.
So -3.
Right, because this is really a minus -3. So 5 -3 would be my center. What if I knew the center of the circle was at -1, 0, and the radius was, I don't know, something really weird like the square root of 37 units? What would the equation of that circle be, Jane?
X plus 1 squared y plus 0, or just y squared equals 37.
There we go. We say plus y squared equals 37. There we go. Now, if I wanted to go back to the conic form with one of these, what would I have to do, Quentin?
You would have to square and then combine your x's together. Well, put it in descending order.
Yeah, basically just square the binomials, right? Square the first square, less multiply double, then arrange the terms so the x squared comes first, then the y squared, then your x, then your y, then your constant value, all equal to 0. That would be pretty easy to do. What's a little more challenging is what we looked at in our last lesson, and that is if I gave you the conic form. Getting the center radius form. Because again, two things I have to know about my circle, center and radius. And in the conic form, the center and radius don't pop off the page, or in this case, pop off the chalkboard at me, right? So I've got to find a way to go from this to this center radius form. What did we do first? This is where we're going to really test your memory here. And if you don't remember, that's okay. Do we remember, though, from a week and a half ago, what we did to get the center radius form from the conic form?
First, you would move your constant over.
Okay, we're going to ditch the constant, make it a 14.
And then group your x's and y's.
Good, get your x terms together. Now granted, I know one's an x squared, one's an x to the first, but they're not like terms, but they have x's in them, right? That's what I mean by group the x's, that's what he meant as well. And then get the y's together, get the things that got y in them together. But I leave little gaps here because, Jamie,
Are you going to complete the square?
we're going to complete the perfect square trinomial in each case. Now, to complete the square, we have to look at this b value, or the coefficient of the first power. We got to do two things to it.
Half and square.
Hey, really good. Half inch square, good. And so what goes in this gap here, Jamie?
9,
A positive 9. Always going to be a positive because we're squaring, right? And then what goes in this gap?
4.
A positive 4. But what will you do to one side?
Go to the other.
Right, I can't just arbitrarily add a 13 here. I've got to also add the 13 to the other side as well. Then I'm going to be able to take the two PSTs and turn them into the binomial squares. So, Jamie,
X minus 3 squared plus y plus 2 squared equals 27.
so what is the center of my circle class? 3, -2. And what's the radius?
Square root of 27.
Square root of 27, which we always would reduce, so we'd say that's,
3 times square root of 3.
yeah, factor 9 times 3, take the square root of the 9, you get 3. 3 times the square root of 3 units. It's a little more than 5, right? About 5.3-ish, maybe, if you have a calculator, square root of 27. Like 5.3?
5.19.
Oh, we'll get closer to 5.2, 5.19 or 5.2. So if you were graphing this, right, if you had your compass, which tomorrow you will, you would go to 3, -2, you put your center, then you have to go measure out 1, 2, 3, 4, 5, and then just go a little bit past the 5, right, about 5.2-ish, and then you just draw your circle there. Questions on this? This is all what we've been covering, questions. All right, let's review then with this, practice with this some more rather. Page 232 in your textbooks. Page 232 in your textbooks. Feel like most of the rust, though you didn't seem to have a whole lot of rust, but most of the rust taken off now. Page 232, number 1, letter B. They give you a conic form. They want to know the center and the radius. They say to graph it as well. Again, for sake of time, today we won't, tomorrow we will. If you're watching at home, though, you want the extra practice, certainly wouldn't hurt. I forgot to warn them ahead of time to bring a compass today. I say warn, like bringing a compass is a bad thing. I forgot to advise them to bring a compass today. Instruct them, tell them. All right, what do we get for the center on letter B? Quentin?
0.
I'm sorry?
0.
Well, the center would be a pair of XY
Oh,
coordinates.
you said 0.
The center.
4, 0.
Jamie?
I have 2y.
Okay, let's take a look at this. We've got x squared. We're going to group the -4x with it. We've got our y squared. There isn't a y to the first. All equal to 0. We really only need to complete the square here, correct? What goes in the gap?
4.
But if we put it on one side, Quentin, and I'm pretty sure you forgot to do that. Is that right?
I didn't complete the square, I just...
Okay. Does it make sense now? So complete the square and then add to the other side as well. Then we're going to turn this into the binomial, which Jamie did.
X minus 2 squared.
Now right here, Jamie, it says y squared, and I could leave y squared, but y squared could also be y plus 0 squared, which could also be y minus 0 squared, right? All equal to a 4. So now we can see the center a little more clearly, class. 2, 0, right? Not 2y, but actually 2, 0. And then the radius is, well, 2. The square root of 4, so 2 units for the radius. So again, if you were graphing this, you go to 2, 0, measure to the origins, that would be 2 units, and draw your circle. It looks something like that-ish, whatever. The compass helps. All right, questions. All right, do letter D. Letter D. There was some rust to shake. That's okay. All right, what'd you get for the center this time, Jamie?
1, 4.
1, 4. And for the radius, Quentin?
5.
5. We're going to go on that one?
5 for the
Okay, let's take a look. We had x squared, group the negative 2x, leave a gap. We had the y squared, group the negative 8y, leave a gap. We've got the 8 on the other side already. Complete the square with a 1, and here half and square gives you a 16. So we're going to add a 17 on the other side to get the x minus 1 squared plus y minus 4 squared equals 25. So there's the 1, 4, and there's the radius of 5.
So how I only had a 17, I forgot to have the 8 on.
You just didn't copy the 8 down. Okay, all right. Let's do letter H. Letter H. This one's going to be mildly annoying, but not awful. If it just said x squared plus y squared equals, of course, I know I have a circle, and it's centered where? If it just says x squared plus y squared? Origin. As soon as you introduce an x to the first or a y to the first, it moves the center. Do we remember what that term is? It starts with a T. Going along with the K3 students across the wall. Translated. It translates the center. It moves it somewhere. In this case, we're going to shift it horizontally, right? But we do need to complete the square. The x I could already write as x minus 0 squared if I wanted to. Here, we're going to fill in the gap, and it's not pretty, but what goes in the gap? A 49/4. Half of 7 is 7 halves. Squared is 49/4. The saving grace is the fact that they gave you a 0. That's actually a real blessing, because when I add 49/4 to 0, it's easy math. 49/4. I'm going to make the binomial squared here.
Y minus 7 halves.
Y minus 7 halves, all equal to 49/4. So I can see the center has been translated in the y. My center is, Quentin? 0, 7 halves. Or if I wanted to, for graphing purposes, think 3.5. That's fine. Nothing wrong with 7 halves or even 3.5. And then what's the radius going to be here, Jamie?
7 halves.
7 halves as well, or 3.5. So again, you're just shifting vertically 3.5 units. Right about here, open that same 3.5 units back to the origin with your compass and make a circle that looks a lot better than that. All right, questions on that? All right, drop down to number 4 now, and some of the problems we work, of course, involve a little bit more thought. So let's take a look at number 4. Read it for us, if you would, Jamie.
Find the equation of the circle tangent to x plus y equals 10 and concentric with the circle x squared plus y squared minus 6x plus 2y equals 10.
All right, so here's the deal. I'm not entirely sure how the picture works, but there's this circle named x squared plus y squared, help me, minus 6x plus 2y equals 10. This is a circle that they give me. They also say there's this line over here called x plus y equals 10. Now, we know that if our circle is going to be concentric with theirs, concentric means it has the same center. But their circle, presumably, is not tangent to this line. It either misses the line or maybe it intersects it twice. But there is one circle we could draw that would still be concentric here, but would just be tangent. That's what we want. Well, again, there's really 2 things you have to know about a circle. Center and radius. Once you know those 2 things, you have the circle essentially solved. Well, the first clue is it's concentric with their circle, meaning it has the same. So if I can find the center of their circle, I know the center of my circle. At your seats, find the center of the circle. All right, what is the center of their circle, class?
3, -1.
But if that's the center of their circle, that's the center of my circle. So far, so easy. Any issues with concentric? Shouldn't be. Now, here's the real kicker. I've got to make my circle tangent to that one. Which means, I need to know what? The radius. Because the radius is going to be perpendicular to the tangent at this point of tangency, correct? Perpendicular. Thoughts? Negative reciprocal slope. And in fact, the perpendicular from a point to a line is the distance. Remember talking about that in the last chapter. Distance from a point to a line. And the key is, because it's perpendicular, I know that my radius line, I don't know the length of it yet, but I know the equation of it has to start how? This is their line. My radius is going to be perpendicular. Remember, if you have a line in general form, ax plus by equals c, the perpendicular is going to be bx minus ay equals d. So my line is going to be no, 1x minus 1y. We're just changing it, because these are both 1s, right? So when you switch them, they're still 1s, but then I change that middle sign. 1x minus 1y equals something. However, my line, 1x minus 1y equals something, I know one of the points in. The 3, -1. So in for the x and in for the y, I can plug those in long enough to get my d value, if you will, or my constant. 4. So my line, now granted, this isn't, the line obviously extends infinitely because it's a line, right? But my line, x minus y equals 4, and their line, x plus y equals 10, have to intersect at this point that is going to be the point of tangency. How do I find the point of tangency? System of equations, absolutely. We'll take their line and my line, and fortunately they were nice to us for a first day back, and we can solve it possibly in our heads. X does equal 7, so y
or
3. 7 plus 3 equals 10, and 7 minus 3 equals 4. So apparently this point of tangency here is the point 7, 3. Now, if this center is at 3, -1, it's their circle and my circle. If the point of tangency is 7, 3, how do I find the length of the radius? Yeah, just use the distance formula. Remember, it's going to be the change in x squared plus the change in y squared. So, what is the change in x? Squared? What is the change in y, Jamie?
4.
Squared?
16.
And that ends up giving us the distance, which happens to be the radius, is the square root of 32. I'm actually going to leave it like that, because I now have my center and my radius. So, what's the equation of my circle, Quentin? Jamie, help.
X minus 3 squared plus y squared equals 32.
There we go. Starting in the center radius form. Now, they gave me their equation in conic form. I'd like this to be in conic form. At your seats, expand that out to the conic form.
Okay, yeah, I see.
All right. Notice, by the way, x squared plus y squared minus 6x plus 2y, all of that's a perfect match, because all of that tells you where the center is translated, correct? The only difference is they had an equals 10, we have an equals 22, or technically conic form minus 22 equals 0, right? That value difference shows the different size of radius, and that's it. I don't even know what the radius was on this, because I don't care. Now I'm curious, actually. Is it 0? No. Can't be. That would even be a circle. Anyway, I just decided I definitely don't care what their radius is. Questions on this? All right. Well, let's do a little bit more. If you can set your books aside and just have your notes out. Let's kind of summarize this section on circles as we wrap up this section on circles today. Let's review over what we've talked about so far. Making sure I'm clear. Let's suppose we've got a circle. The center is at negative 2, 7. Let's go with negative 2, negative 7. And the radius is 10 units. What is the equation in the conic form? Match seats. Once you finish the first, go on to the second. Check your answer to the first. Are we good?
So, okay, yeah.
Any questions at all on the first problem? All right, I'm going to erase you, keep working on the second. Finish with the second one. Once you finish the second, you can go on to the third. You're finding the center and radius and graphing. Now again, today I know I didn't have you get your compass. If you're watching at home, by all means use your compass. Today, just do your best sketch possible, but do use graph paper. Tomorrow, you'll have opportunity to use a compass and make a nice graph. If you're finished with the second, go on to this third problem here. All right, check your answer to the second problem. Are we good to go on that second problem, given the endpoints of a diameter? Finding the midpoint, which would be your center, and then finding the distance from the center to one of the two endpoints to get the radius. Any questions at all there? All right, going on to the third problem then. All right, did we get this center and radius? All right, checking your work. You added the 4 and the 9, so did you add the 13 to the positive 3?
I add, well, I had moved the negative number as a positive and then completed the square.
Before or after you divided the 3? Or did you not divide the 3 up front?
I divided the 3 after I completed the square.
Oh, you can't do that, okay? Because the key to completing the square is that you have a 1 right here. Otherwise, you can't actually half and square. You'd have to half, divide out the 3. So half this is 6, divide out the 3, then square, and then multiply the 3. It's a really weird process if you don't have a 1. So that's the key. We got to get the 1s then complete the square. Does that make sense now? So knock the 3 out of everything. You could move the 9 over at the same time because it's still going to be a 3 over here. Then after that, the half inch square is easy. Make sure we add there and so forth. So for the graph here, Quentin, again, I'm just going to do a quick sketch for now, but of course, you know, if you had opportunity to demonstrate how well you know this in the not too distant future, you would have real graph paper, or at least a graph grid of some kind, right? And you would put the center at
2, -3.
into quadrant. Two -3 is in which quadrant?
3.
Ooh, wait. 2 negative.
2. Yeah, 4.
Quadrant 4, right? So over 2 and then down the 3. So you'd be right here for your center. And again, you would open your compass up 4 units. So if I go 4 units, here's 3 units up, right? So I could open to here, or I go 2 units here and then 2 more units back is still 4. Or I could open out to the 6 because that's 4. Or I could open down to the -7 because that's 4, right? And if you're freehanding it, probably do a sketch something like this and then just try to round it out a little bit better when you actually draw the actual circle. Not great, close-ish, right? Probably about the best I'm doing without a compass. Did you have something along those lines for your sketch, Jamie?
I forgot I put it in quadrant 1.
Okay, you forgot the negative.
Yeah.
All right. Questions on this? Tell you what, if we have time, I'll give you another one like this. For now, go on to problem 4. Did we get this for their circle?
I have 45. I didn't do the 4 over.
You know, the beautiful thing is it doesn't matter, because this radius is 7, but that's not my radius anyway. So I really don't care. As long as you got the correct center, I don't really care what their radius is. My radius is going to be the distance from the center, that is the same as theirs because it's concentric, and right, this distance here, that's the radius. So we're going to have the square root of 81, 9 squared, plus the square root of 49, 7 squared, which gives us the square root of... And so, what is my circle's equation? Quentin? Not the final answer, not the conic form yet, but what's my circle's equation?
X plus C squared plus 130.
There we go. But since they said they want it in the conic form, Jamie, I've got to now blow it back up into the conic form.
X squared plus 12x plus 36 plus y squared minus 6x minus 6y plus 9 equals 30.
There we go. And then to make it look pretty, Quentin?
X squared plus y squared plus 12x minus 6y plus or minus 85 equals 0.
I believe that is correct. Yes, there we go. Questions on that problem? All right. Do we want another one like that for practice? You're good. You're good? Okay. Last one. We might have time to fit this in now. We've got just a few minutes left. Let's try. Let's go ahead and try to fit this in here rather than making it homework. I want you to graph this equation here, which means we got to find the center and radius. Always comes back to the center and radius. Hold on. That's supposed to be a 20y. I'm not that evil.
Yes.
I was like, wait a second, something's not right. Yeah, my bad. Copy error. Again, if you have real graph paper at home, use it. Or if you have real graph paper at your seat, it might be good to use it as well. What is my center? And the radius? So ish, and then something like that? All right, questions at all? All right, tomorrow you're going to have a quiz over circles. I've been hinting at it this whole hour. Okay, tomorrow you'll have a quiz over all things circles. In addition to preparing for the quiz, doing whatever you feel is necessary. Maybe you go back and rewatch some of the review. Maybe that's what you do to review, whatever you do to review to be ready for a quiz. Also, I want you to read over pages 233 to 236. Read over pages 233 to 236, not because I think you're going to understand everything you read, but because by seeing it once, when I teach it tomorrow, it'll make more sense because you've at least seen it before. Even if you read through and you're like, I have no idea what it's talking about, it's still going to help you. Okay, so read over 233 to 236. Of course, that's not on the quiz. Quiz is just over circles. We'll be starting parabolas tomorrow after the quiz over circles. All right, have a wonderful rest of your day, and you are dismissed.